Chapter 7, Day 9, we are going to work on learning targets H and I, and we are going to work on writing numbers in scientific notation and standard form. So, scientific notation is a shorter way to write very large or very small numbers. And they're written as a product of two factors in the form a times 10 to a power. Now, this first number a always has to be between 1 and 10. So it has to be greater than or equal to 1 but less than 10. So it has to be a single digit or a decimal type number that can be 1 point something all the way up to 9 point something, but not all the way as large as 10. And the other thing to keep in mind is that the exponent n has to be an integer, okay? So that's a positive or negative number. So you can see some examples down here of some numbers that are written in scientific notation. Now, a lot of times in science, you might see these numbers written as well. That's a good application there. Okay, so when we look at this, a times 10 to the nth power, the first part is a number, again, I've mentioned this before, that is greater than or equal to 1 and less than 10. So again, that first part, that first number, a, has to be greater than or equal to 1 but less than 10. So those are some examples for a. And the second part is going to be a power of 10. So it's 10 to a certain power. So when we write a number in scientific notation, we're going to move the decimal point to the left or right until we have a number that's between 1 and 10, basically. And the number of places you move the decimal point is the exponent that you use. So, for example, 29,400,000, okay? That's a very large number. So you can expect the exponent to be positive because you're going to be multiplying by 10 over and over to make it a really large number. So what we do is right now the decimal point is right here. So it's 0.0. So I have to move the decimal point over 1, 2, 3, 4, 5, 6. Right now that gives me 29.4. That's not a number between 1 and 10. So I need to move it one more place, which gives me I moved it over 7 places. So then the number part, the a, is 2.94 times 10 to a power. Remember, the number of places that I moved the decimal point over is the exponent. You make it a positive exponent, it's a really big number, or a negative exponent if it was a really small number. So if the number is small, like this one, what's going to change is that your exponent is going to be negative. But we do the same thing. We start where the decimal is and we move it over 1. We move it over 1, 2, 3. That's 7.63. Yep, that's a number between 1 and 10. Times 10 to a power. How many places did I move it? 1, 2, 3. So it's going to be to the third power. But that would mean it would be a big number. This is a small number, so it's going to be a negative exponent. Okay, it's your turn to try. So pause the video and then restart the video to see if you got them correct. So you should have 5.432 as your a value or number between 1 and 10. Times 10 to a power. It should be a positive exponent, and you move it over 1, 2, 3, 4, 5, 6, 7 places again, so 10 to the 7th. This, the number part, is 7.84. There's your number between 1 and 10. And I move over 1, 2, 3, 4, 5 places to get there. It's a very small number, so it's a negative exponent. So that's how this works, to take a number that is in standard notation or just a plain old number and write it into scientific notation. So what if we want to go from scientific notation to standard notation? So when we write a number in standard notation means the number is written out kind of in its long form. We move the decimal point the number of places the exponent value is. If the exponent is positive, we have to make the number bigger. And to make the number bigger, we're moving the exponent to the right. So with this example below, if I moved the decimal point this way, my number would get smaller. So I have to move it to the other direction, to the right. 1, 2, 3, 4, 5, 6. So this becomes 5, 9, 8. And then now I need to add zeros for all of these other places, 1, 2, 3, 4, that I moved the decimal point over. So 1, 2, 3, 4 more zeros. Now I put my commas in after every 3 numbers, and so I get 5,980,000. If the exponent is negative, it makes the number smaller, we know. So to make a number smaller, we move it to the left. So I need to move it 8 places. That was 1 place. So 2, 3, 4, 5, 6, 7, 8. Okay, so now if I count those zeros, this would be 1, 2, 3, 4, 5, 6, 7 zeros that I need. So here's my decimal point, 1, 2, 3, 4, 5, 6, 7. And then I need the 2 and the 3, and that is my number. This should be familiar because I'm sure you've done these before. So your turn to try to put these 2 numbers into standard notation from scientific notation. Okay, this is a positive exponent, so we're making it 4 times 10, 4 times bigger. So every time I move it over 1, that's multiplying it by 10. So 1, 2, 3, 4. I'm going to need 2 more zeros after those numbers. So my answer would be 79800, or 79,800. The second example, it's a negative exponent, so I need to make it smaller 3 places. 1, 2, 3. I'm dividing by 10 3 times. And so again, count those extra places here, and that is 2 more zeros. So this is going to be 0.00143. Okay, so what if we have a bunch of numbers in scientific notation? Is there a way that we can put them in order from least to greatest or greatest to least without having to write the numbers out? You always have the option to write the numbers out, but look at these exponents. You'd be moving these a lot of places. And so that gets a little tedious. So what we can do is we can look at the powers. And the larger the power, of course, the larger the number. But if the exponents are the same, then the larger the first number is, the bigger the number. So what is the largest exponent we have? Well, 49. So if I'm going to put these in order from the largest to the smallest, that one would come first. So 3.2 times 10 to the 49th. Now my next largest power is 41. Well, they're both the same. So how do I know which one is bigger? I look for the bigger number. 8.4 is bigger than 7.89. So then my next one in order would be 8.4 times 10 to the 41st. Then I would have the 7.89 times 10 to the 41st. And then the last number that I would have is the 35th power. So that would be 4.23 times 10 to the 35th. Okay, so be careful, because you have to make sure the numbers are in scientific notation before you order them. Because right now that's a 7 and that's a 5. But notice, that's not a number between 1 and 10. The second number is in scientific notation, the first one is not. So I need to change this into scientific notation. And so I need to move the decimal point over 2 places to get 8.1 times a power of 10. Okay, so in order to get to that number, I had to divide by 10 twice, which means to sort of get back to the number, I'm going to have to take that exponent. So you can kind of think about it like this. If this is, if I was to take the original number and multiply it by 10 to the 7th power, I'd be moving it this direction 7 times, but now I'm going to have to move it 2 more times just to get back to the number. So this is going to be, since I divided by 10 twice, I'm going to have to multiply by 2 more powers of 10, and so it becomes 7 plus 2 for my exponent, or 10 to the 9th power. And then I have 8.5 times 10 to the 5th. So you always have to be careful, okay? And make sure that the numbers are in scientific notation. Okay, so your turn. You try this, pause the video, and see if you can put these in order from least to greatest. So this time we're putting the smallest number first. And then restart the video to see if you got them correct. Well, first of all, we should take this number right here and put it into scientific notation. So I need to move the decimal point over 1, 2, 3, 4, 5, 6 places. So this is 1.98 times 10 to the 6. Again, a positive exponent because it's a big number. So now let's look at our exponent. I have a 6, a 3, a 3, and a 5. So my smallest is going to be 10 to the 3rd. But look at this number. That is not in scientific notation. That one, I need to move this over and make it 8.1 times 10 to the, and again, this would be to the 4th power. Because I divided by 10 once, I'm going to have to multiply by another 10 in order to get the actual number. And if you're not really sure, like in this case, you could certainly process it through by going, oh, this really is the number, you know, moving this over 1, 2, 3 places. This is the number 810. So now I move that over, and actually I did that wrong. That should be 1 less, so to the 2nd power. All right, so now we can look at all of our exponent, and that would be the smallest one. And so that would be 810. I guess I could go back and finish writing this. This would go to 8.10 times 10 to the 2nd. So there's my 0. And that will be my smallest number. So I have 8.1 times 10 to the 2nd. Now I have my 10 to the 3rd, 2.1 times 10 to the 3rd. Now I have my 8.5 times 10 to the 5th. And my largest number is 1.98 times 10 to the 6th. All right, so it gets tricky putting these numbers if they're not in scientific notation, and it just takes some practice. So first of all, which numbers are in scientific notation? Okay, this is in scientific notation because it's a number between 1 and 10. Okay. This is a number in scientific notation because 6 is a number between 1 and 10. This is also in scientific notation, as well as this. So those are the 3 that aren't, or that are. So let's look at why these aren't. Okay, this is not a number between 1 and 10. It would need to be 4.921 times a different power of 10. So again, in order to go from 49.21, I went to 4.9, which means I actually divided by a power of 10. And so I'm going to have to add 1 more power to get back to that number. Or in other words, think of it like this. Again, here you are going to the 7th power. So 1, 2, 3, 4, 5, 6, 7. But now I'm way over here instead, so I have to add 1 more power. So if you went from a larger number to a smaller, you're going to have to add more powers of 10. If you went from a smaller number to a larger, you're going to have to subtract some powers of 10. The reason why this one is not is because it has to be a number between 1 and 10, not including 10. So it has to be less than 10, and that 10 is not less than 10. So what I would do is, again, what I would do with this question is, here's where my decimal point is now. This is 10.0. So in order to move it, it would be the number 1. So this would be 1 times 10 to a power. So then again, what do I have to do? I made a larger number smaller. So in order to do this, I'm going to have to add one more power of 10. Or in other words, this is 10 to the times 10 to the third power. So I would be moving this over 3 places, 1, 2, 3. Since I'm over here now, I would have to, instead of here, I would be moving it 3 places. So now I've actually had it to the 4th. Again, tricky, but just keep working on it. This is not a number large between 1 and 10. It's too small. It's less than 1. So again, what I need to do is I need to take this decimal point and move it here. So this becomes 7.6 times a power of 10. So I made a smaller number larger. So that means I am going to have to subtract 1 power of 10. So that's going to be 10 to the 5th. And again, if you're not really sure what's going on, I will tell you to just go ahead and take the original number right here and write it write the plain old standard notation number. So 1, 2, 3, 4, 5, 6. Okay, that's how many zeros would be with that number. It's a large number. But now that you're starting with the decimal point here, instead, you're going to have a power of 1, 2, 3, 4, 5. And finally, this last one, we cannot have a decimal or fraction as an exponent. It has to be an integer, which is a positive or negative number. All right, so that's the end of our day 9 video for chapter